So here is our second question. This question states that we have a uniform sphere and directly above this we have a uniform ring of mass small m. The radius of both the objects is a and the distance between the centers is root 3a. We need to find out the gravitational force exerted by the sphere on the ring. So now, as I said in the previous question, for all calculations for a solid sphere, if the object is outside the sphere can be replaced by a point mass kept at its center. So let us modify the question a bit. The modified question becomes, this is the ring of mass m and we replace this by a point mass m, capital M, kept at the center of the sphere. The radius of this ring is a and we need to find out the gravitational force exerted by this small mass m on the ring. Now by Newton's, it is very difficult to find out the force by this mass on the ring, because you have to find out the forces acting on each part of the ring due to this mass, and then you have to take the resultant of those forces, but that is very difficult. So what we do is, we find out the force acting on this particle due to the ring, because we know that by Newton's third law, the force which is exerted on the ring by the sphere is equal to the force exerted by the ring on the sphere. Therefore, we find out first the force exerted by the ring on this particle to find out the force exerted by the ring on the sphere. So, we already know the formula for the gravitational field at the axis of a ring, which is equal to at a distance r from the center of the ring on its axis is equal to gmr upon r square plus a square raised to the power 3 by 2. You should also remember this formula, where a is the radius of the ring and r is the distance from the center of the ring on the axis of the ring. So we replace this r by root 3a to get the gravitational field at this point. So we get the answer as gm root 3a upon root 3a whole square plus a square raised to the power 3 by 2. This is equal to root 3 gm small m upon 8a square. Let me rewrite this, root 3 gm upon 8a square. This is the gravitational field at this point in this direction. So for finding out the force on this mass m, we simply multiply this field by the mass m to get the resultant force acting on the particle by the ring in this direction. So the gravitational field or the gravitational force acting on the ring by the sphere is equal to the same in magnitude but opposite in direction, in downward direction. This is our final answer.